and thank you, everyone. I really appreciate the chance to be in conversation with you. Quiero también decir que es una maravilla estar en compañía de tantos académicos e investigadores hispanohablantes en el campo del diseño computacional. Es una maravilla, tenemos que continuar la conversación. Something that makes discussions about artificial intelligence difficult, in my view, is the fact that the term is not very specific or scientific. It is instead a promotional one that we use to market a very broad range of computational and statistical methods. And this lack of precision gives the concept a sort of agency of its own that creates the impression that AI refers to something that is imminent, inevitable, and uncontroversial. This something takes the shape, often, of a sentient and all-powerful being, the fantasy of a species that is co-equal, if not superior, to humans. And I start with that because the theme of the conference is storytelling, and I think that AI is, more than anything, a story that we tell, a story that is populated with biological metaphors that equate neurological and brain processes to the activation of computational filters and human reasoning to probabilistic arrangements of strings of text. My approach to the subject, which I will try to articulate today, is that this story obfuscates, obscures the social, material, and environmental substrates and effects of these technologies, but also their creative potentials. Scholars of science and technology studies and other fields have pointed out how AI technologies may be seen as convoluted forms of outsourcing because of their reliance on the invisible labors and on deepening extractive economies which aggravate the climate crisis. AI systems thus inscribe a certain politics. Artist Beth Coleman's words come to mind when she writes that the instantiation of intelligence, how it is legible, and in what ways it is authenticated and authorized, seems always to be an inscription of power. Contesting those inscriptions is thus critical in the current moment. As anthropologist of technology Lucy Suchman suggests, it is important that we challenge the thinginess of AI, its apparent materiality, and recognize it instead as the confluence of multiple factors and controversies. I believe that new forms of architectural imagination, speculation, and critique can be advanced if we recognize these complexities. To do this, we must challenge the dominant story of AI and craft new ones. I will draw clues from a sort of prehistory of generative AI to reflect on the contemporary technological moment and its hazards. I will then draw from the work I do with students in my group at the Computational Design Laboratory at Carnegie Mellon to show three conceptual tools that I think make these hazards visible and help to build a critical and yet playful agenda for architectural research today. Despite the aura of novelty that accompanies artificial intelligence methods, dreams of adaptive design machines and autonomous creativity have long populated the imagination of computationally minded architects, designers, and artists, and that of artistically inclined mathematicians, scientists, and engineers. Take, for example, the work of Frederick Brooks and his collaborators at the Harvard Computation Lab in the 50s. They developed a method for generating musical tunes automatically by numerically encoding and analyzing the structure of 37 sample melodies. Brooks counted the number of occurrences of specific melodic sequences and created frequency tables, basically a probabilistic description of the dataset. For example, a 0.2 probability of the note A following the musical sequence C, E, G means that the note A follows 2 in 10 occurrences of the C, E, G pattern in the set. So, from here it's easy to imagine a computer program that generates random numbers, and if they fall within that range, it could compose the sequence C, E, G, A. Brooks and collaborators did that. They created such a program and generated new melodies that fit with the musical pieces in the original dataset in a certain sense. Another early explorer of computer music, US chemist turned composer Legerand Hillier, further illustrates this aspiration to simulate inductive reasoning. In the late 1950s, Hillier and his collaborators at Illinois modified a computer program that was used for calculating the geometry of molecular bonds, basically an early chemistry software. And they adapted it to generate melodic lines, transposing the structure of tetrahedral carbon bonds into the structure of musical counterpoints. This transaction is, I think, quite interesting. The program generated melodic samples using the Monte Carlo method, a stochastic process weighted to select results conforming to predefined attributes. Instead of deriving these attributes from a statistical analysis of music by other composers, as in Brooks's experiment, Hillier followed a different approach. He developed style rules that, in his mind, captured the stylistic traits of the dataset. Then they encoded these rules into subroutines and used a program to test random melodic sequences against those subroutines or stylistic rules. And the stylistic rules were things like no tritons are permitted, or the melody should start with middle C, and so on. If the sequence conflicted with any of these rules, it was rejected, and a new sequence was automatically generated. The counterpoint rules encoded in the program were derived from methods of composition from a particular composer, 18th century Italian composer Palestrina. So this is a sort of archaic or early form of style transfer technology. If Brooks used a probabilistic description of a curated set of sampled melodies to shape the melodic outcomes of a computer program, Hillier used stylistic rules, a slightly higher level of abstraction description. These inductive processes anticipate present-day applications of AI in generative design, and more specifically, machine learning in different fields. Meanwhile, researchers in visual fields explored similar questions: how to shape the vast spaces of possibility, the vast abundance of possibility afforded by computational methods, and generate meaningful outcomes. But their material was different. While musical scores could be represented as one-dimensional sequences of numbers, shapes, colors, and volumes, visual imagery required Cartesian coordinates, but the spirit was the same: rules, probabilities, combinatorics, etc. Along with stochastics, this became part of a new expressive repertoire enabled by early AI methods. Artists like Vera Molnar, Georg Nies, Frieder Nacke illustrate this tradition, which instead of synthesizers and speakers used pen plotters. Architectural representations soon became the subject of similar explorations. An interesting example is US mathematician and design theorists George Steiny and the late James Gibbs, who defined design computationally as a visual algebra where shapes themselves are the units of calculation, a theory and a praxis they called shape grammars. Like Hillier and Isaacson, Steiny and Gibbs were familiar with earlier experiments in computer art, but they were also inspired by developments in modern mathematics and generative linguistics. An important difference between the work that Steiny and Gibbs did in the 60s and 70s and the work that I was showing earlier is that they were not encoding these shapes numerically. They were thinking of the visual shapes themselves as computable entities and developed a mathematical scaffolding for that. In the late 70s, Steiny and the late Australian architectural theorist William Mitchell set out to codify the design principles of Italian Renaissance architect Andrea Palladio into one of these grammars. They wanted to capture Palladian architecture in a quote-unquote modern and generative form. They examined the writings, the build works, they did old-fashioned architectural research, and based on the study of all the available works of Palladio, they developed around 90, I think it's 99 rules of style that they claimed were able to codify and produce any Palladian building, as well as new buildings that responded to the same design logic. Again, we're talking about a sort of style capture or a style transfer using a logical system. They imagine a grammar to perform descriptive, analytic, and generative functions. In other words, it should characterize the traits of Palladian buildings, determine if a given design fit within those constraints, and then should be able to generate entirely new designs. They also place the emphasis on the open-ended nature of the resulting grammar and the extent to which it codified the Palladian style. This is, to me, interesting because it is as much a work of computational design theory as a work of architectural history. It's that combination that I think is quite interesting. At the same time, researchers across engineering, mathematics, and architecture experimented with early AI ideas, using software as a canvas to reimagine design itself. For example, during the post-war era, early computer-aided design researchers imagined computers as quote-unquote perfect slaves of architects and artists, taking care of the drudgery of physical labor and calculative tasks. Some experimented with software to advance visions of modular and participatory architectures, urbanism, and artistic practices. They saw in the computer the potential to bridge technical rationality and the possibility of affording each person a unique experience. There was an interesting convergence of discourses about participatory design, critical perspectives on urban renewal policies in the 70s, and the sort of emerging world of US technology research within universities to create software experiments that codified these visions. What we see on the screen is a reconstruction we did of Urban 5, an early experiment in AI-enabled architectural design developed in 1968 by Nicolas Negroponte. Users of Urban 5 could specify in English a series of design constraints, height, number of floors, access, etc., and the program would produce a design alternative. Or, if unable to produce a solution, throw an error. Negroponte himself wrote that the program inexhaustibly printed garbage. It was a sort of ChatGPT for urban design of the time. Nevertheless, it codified a sensibility about computer-based participatory design that resonated with contemporary concerns. Another early architectural flirtation with AI happened here, just a few, like less than a mile from here. A system formulated by one of Charles Eastman's PhD students at Carnegie Mellon in the early 1970s, Chris Yesius. Yesius was co-advised by noted computer scientist and early AI researcher Alan Newell, and was supported by NSF funding for, quote-unquote, the development of formulations and algorithms for spatial arrangement problems and analysis of hierarchical problem solving. Interestingly, Yesius formulated what I think is one of the first examples of computer-aided urban design. It was a system that it was actually never implemented. We built it based on his PhD dissertation and a couple of reports. But it's based on the idea that you can define units and you can define paths for those units that resemble a sort of site plan, and then the system using a heuristics would kind of locate those units satisfying certain constraints, such as this unit has a view towards that side, or there's an access here, and so on. Aligned with contemporary AI discourse, CISP, which is the name of the system, interpreted design as an algorithmic search through a combinatorial space governed by rules and by constraints. Experiments like CISP and Urban 5 and these historical artifacts were, as you can imagine, not very successful in practical terms. They never really worked or became commercial elements. It would take years for systems like this to actually make it into a commercial practice, but nevertheless fulfilled an important function as storytelling devices, making architecture computational. They were thematically linked to urban concerns, but in reality, their main message was to convey a vision of architectural and urban design attuned to discourses on AI and information processing. It was more attuned to those. They are discursive artifacts more than architectural ones. They're more attuned to contemporary AI discourse than to the realities of Pittsburgh or Boston. These are perhaps the perks of abstraction. I think a lot about that today when we formulate new projects in the lab. These experiments also codify an ambition to define open-ended and yet self-consistent design systems by imposing restrictions through probabilistic or rule-based methods. And these configure what we call today a design space, a space of possibilities and so on, which is such a fundamental concept in computational design practices. They also express a distinctive political and historical sensibility that is inseparable from the Cold War era to ideas about information theory, linguistics, and mathematical abstraction. Also, a desire to codify design knowledge to make it computable and malleable in new ways, playfully and sometimes critically destabilizing architects and artists' traditional modes of authorship. These are the themes that I explore in my work, including this project, Experimental Archaeologies of CAD, where I reconstruct historical computer-aided design systems to recover their tactile, visual, and logical signatures, and which result in interactive installations which bring them to life, so to speak, that represents these historical technologies, making possible, I think, new forms of historical scrutiny, but also opening up opportunities for speculative design of design technologies. These are the themes also that are central to my scholarly research, which includes these two books. The first, Builders of the Vision, is an intellectual history of computer-aided design that is literally the stories that animated our engagement with computers since the end of the Second World War. And the second book, Designing the Computational Image, which I co-developed with my incredible colleague Theodora Barduli, documents a curatorial and research project I started to visually explore these histories in conversation with architects, technologists, artists, science and technology scholars, and historians. So, if you're interested in closely exploring the history and culture of computational design practices, I invite you to take a look. Moving on, what is interesting today is that as we transition from rule-based and symbolic paradigms of computing towards data-intensive computational design systems, some of these sensibilities remain core to a big chunk of architectural research on the subject. And we've seen truly marvelous examples of this in this panel and at this conference. I would like to put on the table that it is also important to realize that with scale, the scale of these AI infrastructures that we are currently building and helping build and propagandize, qualitative changes in our interaction with these systems are also taking place. And I think that the difference between a probabilistic cache, which is the title I came up for this talk, and a space of possibility is not in the technology itself, but in the way the rules of these systems are set up and by whom, the extent to which they are malleable and transparent. I think that when the rules are hidden, when the data is taken as a given and black boxed, we have a system that is shielded from scrutiny and creative intervention, a probabilistic cache. When the rules are visible and the data is recognized as inherently constructed and embedded with intent, including its curation, we are talking about a space of possibility. Note that this is not exclusively an issue of technology. Again, it's an issue of the relations of the technology and its politics. And this is why I also brought our attention to those early experiments in AI because they tell us about what I think are more intimate engagements with the data as a sort of material to be designed and manipulated. They tell us about playful redefinitions of design, creative practice, and authorial agency. They are sort of knowledge-making adventures, which I continue to find inspiring. The opacity built into many of these systems today, by virtue of their scale and their close alignment with venture capital, corporate growth, and the political structures that support them, may prevent such explorations. This opacity presents hazards, a few of which I would like to briefly discuss. One has to do with labor. First, as has been documented, AI systems rely on invisible and often precarious labor. A clickwork industry focused on microtasks, such as labeling data for training sets, prompting some to joke that AI actually stands for, quote unquote, absent Indians. Sustaining the perception of automation, then, relies on making this type of work invisible. But the work of creative practitioners, including architects, visual artists, and writers, is also made invisible when companies use their work without permission to train their models. We are interacting with absent artists. Is it automated plagiarism, or is it simply transformative use? Can a future of AI where these systems cite and compensate their sources be imagined? And what does it mean that our notions of creativity, that these systems work by recombining and interpolating past information? Another hazard is environmental. Scaling AI into a planetary infrastructure requires astronomical and ever-growing demands for storage and processing power, extending our reliance on power plants using fossil fuels. How much longer can we delay serious climate action? It may not be a terrible idea to ask ourselves who is really benefiting and is it worth it? For those of you who are not familiar with the new data centers that Zuckerberg is planning to put all over the United States, their gargantuan scale and monstrosity are captured in the top left image. The last hazard I have time to mention today is the intensification of violence. We know from current events that the most advanced AI systems for facial recognition and for the automated generation of military targets are being used today, as we speak, in support of projects of mass displacement and dispossession, and of indiscriminate acts of urban erasure, environmental destruction, collective punishment, and killing. Ironically, despite the animistic tropes endowing AI with a life of its own, the facts on the ground suggest that these technologies can be used to create worlds that have been literally emptied of life. This is generativity's dark turn. These are, of course, difficult questions. Where do they leave us as architectural and design researchers? How might we playfully, inquisitively, but, to use Haraway's words, engage them while also staying with the trouble? Let me shift now to the work I do with my group at CMU, where we try to retain an experimental disposition while at the same time trying to keep some of these hazards in mind. The way I think about this approach is through three threads or premises that we use to inform a lot of the work that we do. And I will try to illustrate this very briefly through a few projects. I want to be clear that I'm not suggesting that these are solutions to these problems. They are part of an ongoing reflection and experimental path that is ongoing and that I'm excited to share. The first is a recognition that data are not inherently truthful or neutral, but intentional, designed artifacts. This is a point that STS and media scholars have articulated very well over the last decade or so. What this means for us as architectural and design researchers, however, is that the construction of data can be seen as a creative practice in of itself. and I include curation within that aspect of creation. In this project, we focused on a few hundred wooden churches in the Carpathian region of Ukraine and Poland, dating back to the period between the 17th and 19th centuries, which are being targeted as part of the ongoing Russian invasion. Drawing from online repositories, archives, and personal collections, we curated a dataset and processed them using the NERSC method for 3D reconstruction. This resulted in a small dataset of polygon meshes. We then used this dataset to train a deep learning model which extracted and encoded the church's formal features, allowing us to cluster them and to identify stylistic families within it. The study resulted in an architectural distant reading of these Carpathian churches, that is, an analysis that draws from a relatively large collection of examples as opposed to a single building. This resulted in interesting findings regarding their stylistic traits and configuration, as well as their geographical distribution, which we developed in conversation with historians with expertise on this architectural tradition. This suggests ways to use deep learning and 3D reconstruction techniques for architectural historical analysis, scholarship, and digital heritage. What I want to highlight today is the absolutely painstaking, almost artisanal way the dataset was crafted, and the way the team used it to establish a conversation with existing scholars and scholarship about this endangered architectural tradition. The construction of the dataset was a process that enabled us to establish those conversations rather than a final artifact or product. In this project, we generated a new dataset of images for almost 50,000 buildings in Pittsburgh, each surrounded by its immediate urban context. Using TSNIs, we clustered buildings based not only on their individual characteristics, but also on their contexts. Mapped back into space, this clustering produces a new type of morphological plan that redistricts the city based on subtle distinctions in its urban fabric. Key to this project, which was led by one of my PhD students, Jean-Marie, was the development of a custom data structure that encoded a building's geometric features as well as those of its surroundings. This new approach to urban codification resulted in a new sort of analytical and descriptive possibilities. I mention this because it's not just about the algorithms, it's also about the way the data structures that we use to capture the data that we want to analyze that can drastically shape the space of questions we may ask of those data sets. And this hints at the second move, which is the move I call post-disciplinarity, which I think is something really close to the heart of the computational design field. Computational methods have always worked in conjunction with other knowledge domains and draw from a broad range of conceptual and methodological toolkits. Computational design is not a discipline as much as an interdiscipline that emerged timidly at first in the interstices of other fields, like mathematics, engineering, architecture, and the visual arts. And this creates opportunities to loosen, to let go of rigid disciplinary identities and craft new ones that allow us to explore questions in new ways. Jinmo, who led the study I was describing earlier, supplemented it with field visits to what appear to be boundary conditions in the dataset. So again, the dataset and the deep learning analysis was not the end of the conversation, was the beginning of new questions to be asked of the matter at hand, in this case, the urban conditions in Pittsburgh and other cities. He enriched his analysis with qualitative observations, which helped to confirm his findings or to challenge them, enriching the study with a deeper understanding of the historical origins of these cities' fabrics. In this project, we reimagined computationally William White's study of the social life of small urban spaces, which used film, qualitative observations, and clever counting and mapping techniques to gain a better understanding of public spaces in the US. The project was supported by the Metro 21 Institute and the Pittsburgh Downtown Partnership, and it focused on Pittsburgh's emblematic Market Square, which is this space, resulting in a data portrait of its urban activity. Our aim was not to build a predictive tool, but an interpretive one, to trace fluctuations in the use of urban space in response to weather changes and to the disposition of urban furniture. This project suggests applications that inform urban decisions concerning pedestrian traffic, commercial activity, and more. And in this project, architectural research is at the convergence of different kinds of computational and urban toolkits. Here, we're not wearing the hat of the architect anymore, only at least. In this project, we explore new kinds of computational tool-making for creative practice. Ardavan Bidgoli, a PhD student in the group, worked closely with musician Mahtab Nadalian for several months to develop a robotic instrument she would use during one of her Santur performances. The robot is animated by machine learning techniques trained on a data set of movements the musician herself curated. Here, the data is the interface, which is a wonderful articulation by computer scientist Rebecca Fibrink. The data is the interface of the tool. And it's created embodiedly by the musician herself playing the santur. The result of this process is a performance executed by Mahtab with 2 santurs and a robot. And this helps me move to the final kind of premise, which is the idea of social interfaces, the idea of creating opportunities for participation, interruption, and intervention in otherwise intractable computational processes. This is the final conceptual move, interfaces developed with a critical or interpretive intent that afford new kinds of computational transparency or obfuscation or exploration, shaping spaces of possibility. And again, this required to work outside the boundaries of the architectural profession and embrace other disciplinary identities, toolmaker, coder, conversant, ethnographer, to open other paths for creative practice and technological conviviality. My last example is a project called Rethinking Automation in Construction, which explores practice-based approaches to the design of construction support technologies. This means grounding our design of robotic systems for building on qualitative and participatory methods and envisioning the future of construction as a convivial ecosystem where robots are in the loop of construction rather than fully automating it. We followed a group of construction workers in a construction site for several months. This resulted in an ethnographic study of different construction activities. And from here, we started a process of conversations and workshops that resulted on a series of scenarios for robotic support, one of which we developed into an actual technology using a deep reinforcement learning approach, and which we tested in design workshops, simulations in our lab, and actually were able to bring to a construction site here. At its root, it's a project where we probe robotics and machine learning techniques to afford technologies that are trying to insert themselves into existing worlds of practice rather than technologies that absolutely reconfigure them. We use the phrase robot in the loop to try to articulate that reframing. More than offering final answers, or I have tried to offer materials for conversation, what I see as possible paths for architectural research in a moment of technological change. I also try to offer a sense of an experimental sensibility or discovery and technological playfulness, drawing back to the historical origins of AI in design and creative practice. Because I believe that we can imagine a richer poetics of computing if we learn to relish in some of those aspects I mentioned. If we learn to relish on the labors of designing, structuring, collecting data, right? If we embrace these different disciplinary identities, to allow ourselves to ask questions that escape the boundaries of the disciplinary spaces that we are used to occupying. And also, if we allow ourselves to imagine interfaces and systems that slow down computational systems, that create interruptions, opportunities for participation, and what I call social interfaces in this talk. This is what I mean by escaping the probabilistic cages of contemporary AI systems. And this is what I mean when I say that we can try to build instead malleable scaffoldings supporting imaginative and critical architectural work. I look forward to thinking with you about these subjects.
Thank you, Daniel, for this super important perspective on AI, and like also the kind of reminding us of the contested history of its coming into being. I'm just having a quick look around in the audience, see if there are already burning questions. Oh, already there is one. Okay, then I will jump straight in.
This is going to be a technical question, and it's on the project that you show us about the morphology of the city.
Yep.
And it's because I'm also dealing with that question currently,
Yep.
and I want to hear your reflection. There is all of these standards and protocols that we have from BIM, for example, for buildings, and then we have CityGML for cities. So how do you see the attempt of creating a new standard to aggregate data, and how meaningful is that to your project, rather than just joining into open source data structures that are already powerful enough to do exchange and so on. So I have two questions, but this is the first one.
Thank you. Yeah, that's a very good question. The project is not meant to create a new standard. The project was to create to speculate on the codification of urban data to see what kinds of questions could we ask that are different than those that we can ask using current GIS methods. And there is currently no protocol that encodes urban information in the way this project does. And it's nothing too complicated. It's simply that in the data set of these urban artifacts, we decided to include the neighboring buildings up to like a radius of, depending on the city. Imagine a structure of urban data that includes not just the perimeter of the building, but also the surrounding perimeter of the work. This allows for a new sort of questions to be asked about the system. It allows us to kind of map and cluster urban fabrics by virtue of their spatial qualities in ways that current urban structures cannot. But I'm very happy to be clear that we were not trying to supplant or create a new standard, or we were simply wondering, okay, what can we do? What kinds of questions may we ask with that? And what we found is that we were able to find interesting resonances in the urban fabrics of different cities based on this method of analysis. We realized that having created this type of clustering, we could find commonalities between particular areas in Pittsburgh that were historically connected but not adjacent. That helped us to confirm some of the hypotheses that we had. It also helped us to qualify different types of urban fabric that are common to different cities. In the study, we looked at Pittsburgh, but also Detroit, Miami, and others. And we started to find these kind of typologies of urban form that are just kind of a new way of looking at the city.
It is an interesting thought because currently our planning processes rely almost solely into these established aggregation methods like the neighborhood, polyline, or the zip code, or the census tract. And one of the thoughts that I have, because I'm doing a similar, and I will definitely reach out, is the idea of defining buildings for planning.
Mhm.
is whenever you're going to make a decision that will affect a group of people, you want to know that it's not, it's not about fairness, but it's to be able to have a balanced approach to the decision. So if you're going to make decisions about climate adaptation, you need to know that you're serving the people that exactly need
Right.
that help. And not because they are living in the same census tract, but because all of the other features like topographic information, weather-related
Mhm.
information, historical
Mhm.
disaster, and like so many other things.
Yeah, yeah.
So then my question is regarding your second line of the three, I would say, research lines? Or
Yeah, the post-disciplinarity, yeah.
So you have that one, I think it's called data
As artifact, yeah, that was the first, yeah.
certified. I have always this idea of this hierarchical pyramid that computer science talk about data, information, and knowledge.
Right.
So I tend to think in parallel.
Mhm.
So I always have data and information. So I was curious
Yeah.
to hear your thought about when data becomes information,
Mm.
and do you see these in the work that you do? Which
Mm.
I mean, in my brain, the way that I read the work, it does feel. But
Mhm.
I wanted to know if you thought about.
Yeah, yeah. I think the idea I wished to convey with that phrase of data as an artifact is a reframing of the idea of data as something that is sort of inherently truthful. I think we're used, or in architecture, we see a lot of experimentation with existing data sets, and like we are kind of relishing in the profusion of these systems. And I think it's useful to remind ourselves that those data sets are constructed, they are built for certain purposes, they have gaps, they have things. I think that, and there's wonderful work in STS and in media scholarship about this subject that I think is informing this view, the work of Joanna Drucker, for example, or Yanni Loukissas, or other people who have looked at this question from a more socio-technical perspective. Data is not inherently truthful. It's not something that you can mine, and we have all these metaphors to talk about that. It's something that is built, and if we incorporate into our practices a sort of conscientious, reflective approach to building them, then it can become something closer to what I think you mean, to what I think you mean by information, right? Like, for example, when we were working with the churches, right, it was absolutely painstaking, right? Like it was really building not from scratch, but it was really, each one of those was, entailed a lot of effort to build, and to a lot of curatorial decisions about what systems, what buildings to incorporate, and so on. So the resulting artifact, that collection of things, felt very much like an intentional artifact, and I think that's a valuable sort of thing that we should look for when doing reflective architectural research with these type of technologies. At least that's how I see it. Yeah.
Thank you. Maybe like one comment or question from my side. I'm so interested that there is this. It seems in your talk that like we can't escape one cage and we find ourselves in a new cage. We escape the cage from structures and rules and symbolic AI, which like all of that, and then now we find ourselves in probabilistic cage dealing with like a scale that we can grasp, dealing with like the kind of like the sheer material and energy needs to train these models that like we as like architects, as individuals, but not even as research departments can compete with.
Right.
And that's kind of completely weirdly ironic placed as coding architects.
Yeah.
But then I'm wondering if there's if this, and going back to the concept of curation that we discussed earlier, if there's something that can kind of like a practice that can bridge and bring the kind of like the care of the curation of like a curated precious data set together with the kind of the messy black box huge generic data sets of these foundation models. I remember like one anecdote from the beginning of the PhD. I was trying to train a transformer, and then there's this like this tutorial, and then if you like try to train a transformer on all the things by Shakespeare, it will just not work because it's just way too little. If you train it on everything, including like all the Reddit threads, then it's great in writing Shakespearean language. And so, how do you think of these new practices that emerge when we start fine-tuning with like curated crashes, specific data sets, these kind of like underlying monoliths, generic foundation models.
Yeah, it's a really nice question. I wish I could tell you, do this and that. But what I can say is the things I like, things we find useful in the work that we do is to, we gravitate towards smaller data sets, as you saw. Like we work with projects where we have an agency on the curation and development of data sets, even when they're not that small. Like the urban data set of Pittsburgh West, it was not big, but it was not super small. But we go up until the really tiny data sets of the musician working with the Santur and then working with that to develop tools that do take advantage of the algorithmic capacities of these systems to build interfaces that are part of the social kind of context where those practices are happening. Because that's kind of the focus that we have in the group. I think there's a lot of opportunities, and we've seen amazing kind of examples of that, opportunities to use existing kind of data sets and foundation models and so on to work. What I think becomes really useful in those cases is to remind ourselves of the constructed nature of those data sets. We have to, I was living in Germany up until a week ago, and I was fascinated in the supermarkets. Most of the products have this ABCD sort of nutritional value content. So very quickly you can see if a box of cereal is A, which is all nicely produced and so on, and F, it's okay, this is really ultra processed stuff. Maybe we need to think of something similar to the products of this technological moment, when data sets and the products that we create using those data sets are evaluated critically in terms of how they engage with the ethical and labor and questionable practices that we're talking about. I think that when using those systems, and when I work with students who are experimenting with those systems, what I try to ask is that a sort of contextualization of those systems is provided, that they are not used as is, or if they're used as is, they're used advertently and consciously in a way that is articulated. Yeah. I don't know if that helps kind of explain the approach. Yeah.
I don't know that I have a question, maybe more of a comment, and something that I think you also just addressed in your comment. I think earlier on in the presentation you had Kate Crawford and I forget the collaborators, Calculating Empires, which I've been completely obsessed with ever since I've seen it. And, and watching your presentation, it's really interesting to kind of see the hardcore, deep diving into very, very small or very nuanced or very particular criteria within kind of data sets. But the way you presented it, and I think contextualizing that by foregrounding as well, the Calculating Empires word, I think it really comes through how much you're doing exactly that, but thinking about the sort of interrelationships between all of those contributing elements and factors and politics and kind of social experiences and technologies that had input into, let's say, that kind of region of Pittsburgh that you were examining. And as you were looking at that, I wanted to see the data set looked at from all of the Google photographs that are uploaded from all of those, and then beginning to hone in on just all the fire hydrants, and understanding who built the fire hydrant, who designed that fire hydrant, where that fire hydrant is throughout the United States. You begin to connect through all of those kinds of technologies and interrelationships that, even though you weren't talking about it, it felt like having the control that you do over the sets, over the information that you're looking at, you could then easily pivot to any number of those kind of elements that come within your kind of archive.
Thank you. Thank you for that point. I think that that's super important to us as well. That kind of cross scalarity, like to think from the perspective of the data set, but then going deep down and looking at instances. I think that's very important to the work that we do in the urban project that my student Jinmo led. Some of the most interesting, beautiful moments in the research were to contrast what we thought were the findings of the deep learning analysis, and then taking a bus and going there and spending half an hour looking and taking photos of the place. Those photos Some of them came from that. With the church project, we did something similar. And this is actually interesting, I didn't have time to show it, but we were planning to go to Ukraine to do kind of an analysis of 5 of these churches. We got a really nice grant to go, we had the money, and we couldn't do it. CMU didn't let us travel because of the obvious situation. I think it was good that we didn't go, but at the moment it was very disappointing. We did find that here in Pennsylvania, there's a couple of churches that respond to very similar typological and morphological traits because of Ukrainian communities that migrated in the late 19th and early 20th century. So we found actually, like 45 minutes from here, a church that belongs to that family. And then that became an opportunity to go and document that church in all sorts of ways, photogrammetry, laser scanning, and so on. And we created a sort of interactive artifact that allows us to explore it and that tries to do that link that you were mentioning, the link between the sort of the bird's eye view, data view of things and the more tactile, close look, or between the distant reading, to use the term I was using earlier, and the close reading of the artifact. So yeah, I think that's very important. I think that cross-scalarity is central to what we should be doing. Yeah. Oh, that's great to know. Super, yeah. Thanks.
Any more questions? Yes.
Thank you for the very beautiful presentation. I think, and this may be also related to some earlier sessions, earlier presentation today, but I'm really curious what you think about the interfaces, because you're going to talk about what protocols, interfaces, the way we interact with data, but even to the degree of like thinking about BIM or GIS as protocols, right?
Mm-hmm.
How we communicate and eventually how we as humans, try to interface.
Right. Thank you. That's a very nice question. When I think of interfaces, in the context of machine learning and AI technologies, my mind gravitates instantly to slowing down, to making things slower and making things more tractable, and sort of in order to find meaning. Not because I want systems to be inefficient, but because I want things to mean something. And I think a big part of what we can do as architectural and design researchers in the world of AI and design is to design and imagine interfaces that allow for that perceptual capacity of finding meaning and navigating these systems. I didn't show it, but one element of the Santur project was like a very nice visualization interface that my student Ardawan developed to allow the musician Mahtab to kind of select the utterances of her playing to create a data set that then informs the performance of the robot. And I think that's a nice example of how an interface can very simply make a process that is computationally intensive and sophisticated into something that is legible and that is connected to a specific social practice, or artistic practice in this case. In the lab, in the group that we have here at Carnegie Mellon, many of our students develop tools that are very tailored to specific forms of creative practice. And again, we didn't have time to show it, but some of them actually try to open up these algorithmic machineries and allow for different kinds of control, like opening up the filters of a neural network and creating a visualization of the neural network's filters to kind of play with each of them and see what happens, right? It's a little playful but it's what I think about when I think about interfaces and our job as architectural and design researchers in this context. I think we are well equipped to create interfaces that make systems like this more meaningful and more usable and more actively participating of creative work. Yeah.
maybe on that last point, the relationship of the interface and literacy, I think that's a super interesting conversation also to kind of like briefly tap in, because one of the things that, I don't know, like, I'm often thinking about when using GPT is that like we are so dependent on that interface. Like we're given that interface, and a lot of the design, like, I mean, it also already starts in the training, right? Like with the reinforcement learning through human feedback, already that to some extent is an interface design choice of like the tone of the model, how encouraging the model is, how sycophant the model is. There was a big debate recently on this, what the sycophancy of GPTs. And then, of course, the two-dimensional interface with like the text box and the little submit button and these kind of things. So the interface kind of like also automatically makes one a user of a specific product that is like made by like a big conglomerate. If one doesn't have some way of knowing how to code some of that. So how do you, but then without an interface, you would never be able to properly use these things. You would be like stuck in these kind of like Twitter views of some node that nobody understands how it was trained and what weight it has and whatever. So how do you see that relationship between literacy, like coding literacy, and then interface?
That's a super nice question. I think that it's a question that we could ask about different sorts of work. But from your question, it comes to mind the idea that maybe it'll be really fun to have a studio that has as an object interface, like speculative interfaces for AI systems, right? And how else may we interact with these systems? In what other ways? What are these interfaces conditioning us to do or nudging us towards? What different kinds of interfaces, how different kinds of interfaces may result in entirely different transactions with those systems. And I think the coding literacy could be certainly an element of that, and you could imagine that being taught to engineering students, but I think it can also be the subject of speculative thinking and design, and then in places like I mean, we're lucky at CMU, like we have a program that is very much technically engaged, and then you have people coming from architecture, but also from engineering and computer science, working together. So I think creating post-disciplinary spaces as well, where people of different kind of disciplinary identities and persuasions and methodological persuasions can converge, I think can turn something like that into something really interesting. And then, speculative or experimental interfaces for AI, that would be really fun to explore.
Amazing. If there are no more questions in the room, and I think we're going to conclude this.
Thank you.
Thank you so much, Daniel.
Thank you so much.